Okay, so when we're talking about y-axis symmetry, what you'll notice is a couple of different things. One thing is when you graph the picture, you'll notice that you can fold over the picture over the y-axis. Another thing you can notice when you're graphing, if you're plotting it by hand, is that if you put in opposite values for x, your output values will be the same. So in other words, if I have a function like this, y equals 3x to the fourth minus 2x squared plus 5. I could graph this and take a look at the picture of it. Let me see if I can pull this up. Alright, so it's the first equation. And when I see the picture, it does look like it's got the y-axis symmetry. I can also do a numerical analysis on it. Plug in, for example, the number -1 and +1 in for x, and then see what your corresponding y values are. So if you do that, you have to do the powers before you do the multiplication. And when you raise a negative to an even power, it's going to flip it to a +1. So this is 3 times really +1, 2 times +1, and then the 5. So the output is 6. And we'll see the same thing happening when you plug in the number 1. And so we get an output of 6 as well. So even without fully graphing it, I can take a look at where those 2 points are and plot -1, 6 and +1, 6, and see that they lie opposite the y-axis, on opposite sides of the y-axis. For the algebraic proof, though, what you do is you let x equal -x and then simplify it. If you get the same equation back, then you have y-axis symmetry. So for example, if I put in a -x everywhere there is an x in the problem, and then go to simplify it, again, the negative to the 4th power, that would be like writing this out if you had to do this, which I don't recommend, but it might help you see a little better. And then this is -2 with 2 negative x's, and then the +5. So I have y equals, when you multiply negative times negative, it's positive, and another negative times negative, it's positive. So ultimately this is 3x to the 4th, and then -x times -x, +x squared times the -2, and then the +5. So you can see you end up back with the same equation that we started with. And when that happens, then you have y-axis symmetry. That's your proof.